On the agenda today, we have some announcements, a recent release to talk about. Maciej is going to talk about simplified job hierarchy in Spark coming soon, some exciting developments in the Flink integration. And then we have discussion items and open discussion. First up, some announcements. Some administrativa, our Zoom link is changing, so keep an eye out for an updated invite, and we'll, update our Slack announcements and the website, the wiki and so forth. But that's a little change that can make a big difference, as we saw today, right? So keep an eye out for that. LFAI, the logo is on the screen because we're using the LFAI's Zoom, one of the helpful tools that they offer. So I teased this a minute ago, but we want to extend a warm welcome to a new committer on the project, Damien Hawes from Booking.com. Thank you so much, Damien, for all your contributions. We're excited to see what you do for the project in the future.
Welcome.
Yeah.
Welcome, Damien. Yeah, he's not on the call, but just to call out his contributions that we decided to nominate and make him a committer for the project. Basically, Booking has been using OpenLineage for quite some time, but since October or September of last year, Damien's been contributing either cleanup, documentation, bug fixes, but more recently he added support for multiple multiple Scala versions for the Spark integration, which saved us all a lot of headache and a lot of people in the community work. So we really appreciate all the work that Damien and his team at Booking are putting into making OpenLineage better for everyone. Thank you, Damien.
And have a meetup coming up. Mark your calendars. March 19th is the date. We're going to be meeting at the Microsoft New England Conference Center. And this is an event that Astronomer and Calibra are co-sponsoring. It's a data lineage meetup. We'll start at 5:30. There are more details and a link to sign up on meetup.com on the OpenLineage blog. And more details coming soon. An updated agenda will be coming. More information about speakers and so forth. Just wanted to alert everybody about the date. Okay.
I don't know. Oh yeah, just wanted to tell about your calendar.
Oh, okay. Yeah, feel free to jump in, Maciej. This involves you directly. We've got an exciting talk coming up at Kafka Summit. By Maciej and Pavel. It's called OpenLineage for Stream Processing. And that's going to be on March 19th at that conference.
Awesome.
A lot of good stuff happening in March. It's going to be a busy month. In addition to that, we've got a data standardization panel moderated by Julian. That'll be at Data Council. And the date, I was looking for the date in my notes. Is it the 26th? Can we confirm?
It's going to be on the 27th.
Okay.
And the panel will be composed of people we've seen regularly in this meeting. And we're still finalizing the list of participants in this panel about data lineage. It's data lineage standardization panel, not data standardization panel.
Right, thanks.
Live editing, ladies and gentlemen.
Yeah, so more details to come about that. Let's see. Just wanted to briefly give an overview of a great event that we had recently. This was our first London meetup. We did it with Kafka at the Confluent headquarters in Covent Garden. And we had a speaker from Decathlon, we had a speaker from Confluent, and a speaker from Astronomer, Getting Data, who came all the way from Warsaw for the event. Our Decathlon speaker came all the way from Paris. We had a lot of help in making this happen. Olivia Taylor at Confluent deserves a shout out for doing all the logistics over there, and Abdallah for making the trip, obviously, and Pavel for coming. Mandy Chessel, those of you on the call, many of you probably know her, and she was able to come. And Tatiana, some of you might know her at Astronomer. She was there as well, helping out. Anyway, it was a great event. Hoping to share more details about, for example, Decathlon's architecture. We saw a peek at their lineage graph in Marquez. I can't wait to learn more about their use case, but all the talks were great. We had a good turnout, and we're hoping to do more in London, possibly with Confluent. That would be great. These are some pics. This is the graph I was talking about over here on the upper right. But as you can see, we had a large engaged group there. So thanks to everybody for making that happen. All right, so just a little bit more for me before I turn it off. Freudian slip there. Turn it over to Maciej. Since the last call, we released OpenLineage 1.8, and so just to reiterate, we're really grateful for Damien's contributions, but also on his team is Mattia. Bertarello had no fewer than 5 contributions in this release. And a lot of this work is enhancing the Scala support in Spark. There's more than simply upgrading the version in this work, but really big contribution, and there's even more coming. But in addition to that, we saw support for Flink 1.18 added by Peter. That's the first one there. Support for Glue and Iceberg by Natalie, also in the Spark integration. This change in Spark is related to the other PRs, I believe. So thanks to all the contributors, and as I mentioned, these are Mattia's first contributions to the project, so welcome, Mattia. So that's 1.18. You can read more about the release in the GitHub repo, of course, and in the docs. So let me turn it over to Maciej. Would you like to share your screen? Or
No, I think it will be better if you do that. So I have 2 topics for today. One is story, which will be later, and the first one is like a description on how we think of jobs specifically in Spark right now. So what is actually a job hierarchy? Let's say we have a data infrastructure, data platform. There can be 1,000 jobs running daily, and OpenLineage can answer, like, give us an answer to a job data set, to like job to data set lineage, but it doesn't help us to understand some other questions, like why did the job run when it ran, like what scheduled the job, and why did the job run after some other job, right? And we think we can actually answer those questions if we take a look at one specific element of the OpenLineage event. So there is a parent on facet, which we can see an example of below. And for the given run, it tells us whether it gives us the UID and job of the parent job. So what is parent job? In our nomenclature, it's a job that scheduled this particular event. So let's look at example. Can we yeah. So in our flow, it's pretty clear what happens, right? You can take a look at their flow DAG and see how the jobs are structured, right? So we have a DAG, we have a tasks, and those tasks can modify different data sets, but they all have a one parent, which is a Airflow DAG. Now, if we take a look at Spark job in the next slide, it's not so easy, right? So this is a Spark job, or rather what people think of as a Spark job. And we can see like some PySpark invocations, right? We can see that we create some objects and we execute some SQL. And for people, this is their job, what they created, what they execute, and what they expect to see. And in the lower level of Spark integration and what Spark actually thinks of as a job, we can see a few jobs, right? And every Spark SQL statement can be a job itself. We can have more lazy execution, more bigger. It's not always obvious what happens, but what matters for user is that they execute one job. So in this case, we would have for this one singular job at least 8 OpenLineage events, because we create 2 tables and then insert some values into them. But that's not very easy to understand for a user, right? So our idea is that we would have for a given Spark application, which is this Spark job, we would have a single event that is emitted on the start of the job and one emitted at the end of the job. And every Spark action, which is like the execution unit, let's say Spark, would have a parent job. Yeah, and now we can see the more complex example, where we have a Airflow DAG that runs some tasks, and one of the tasks schedules Spark job. And this is actually a really real example. There are multiple operators that schedule Spark jobs. For example, I think there is one for the MR, one for GCP Dataproc, possibly for some Microsoft Azure. I'm not sure. I haven't used that one. So the one DAG to operators, one Spark application to actions. And below, this is very small, I think, but maybe you can see like the actual sequence of an event that we will see from this. So we have a DAG start event, operator start event, and then the operator starts the Spark application, which means again start event. And then we can see Spark action 1 events. There can be more than 2 because we have running events and other events that can happen during execution. Or if it's a streaming job, then for example, we can have also running events. And then the second Spark action, which runs after the first one. And then the complete application event. And then the operator complete event. And then the second operator starts because it depends on the first one and it completes and the whole structure completes. So from the sequence of the events, you can have a clear view of what happened where in the course of your application. And this way, 2 examples of what OpenLineage consumers can do with this information. First, they can collapse the information that they got from the Spark application. So let's say you want to have a simplified view for the Spark, for the, let's say, UI, where you don't distinguish those Spark actions, but just top level view. What data this application, which is dropped in Spark user's mind, what data it reads and what writes without like distinguishing the internals of it. And yeah, that's I think very useful case. Yeah, another I think is showing the actual higher level execution. So if you don't care about like tasks, if you want to see where different things are scheduled, you can like, for example, have a job level view and see what schedules what across cross-platform system. Yeah. So that's what I wanted to tell about this Spark application events. And yeah, just to maybe make it clear, the Airflow part was already working like this. Now we added this Spark application event, which actually makes the scheme more similar between those systems. So any questions about this?
Less of a question, but I think this is a really important addition and really great work. I mean, we also specifically, we have a lot of data catalog people here on the call that will particularly care about this, as it really helps visualize dependencies and governance use cases, kind of imagine, oh, which applications access this data set? It's much easier to answer that visually with this representation.
Oh yeah, and I think it also can, one more use case, you always, with this complete event, you always know when your Spark job ended, right? Because you can have a dynamic job that sometimes creates another actions and sometimes not. So with this, you can know that. And I think that was important for someone. I don't remember who. Sorry. So if there are no more questions, I can move to tell the story and the story of integration.
Just
So-
one quick question. I'm curious about how well this works in the Databricks environment, because I remember Databricks in particular was a bit different from kind of vanilla Spark. Have you tried it out in that environment?
Great question, and we need to try it more in Databricks.
Okay.
But Databricks is always slightly different with like non-standard lineage, logical downloads. Yes, and that's a very hard question. So the story of link integration. Well, we always wanted to have a Flink streaming application integration because like Flink is the most popular streaming system right now. And if you want, like, let's say you are creating an ML model and you want to have new real-time features, Flink is one of the best ways to like have this. And there are a lot of other streaming systems, but I think it's like one of the most popular, open source, and yeah, very popular. So we had an idea to make a Flink integration, and we made one. But how it does look like right now in time. So this is actually a piece of code that they copied from the integration. It's like part of the bigger class. But what you can see is that it's not a very beautiful code. And yeah, what it actually does is a lot of reflection, a lot of instance of, a lot of checking whether something has a type. And if you are like a Java programmer that develops type-safe code, your eyes might hurt right now, or even bleed. Because why is that? Why do we write such code? Because a lot of we don't have a good interface for Flink to actually create the integration. So we decided to make a workaround and basically try to create something that kind of works with existing system, but it's not like our perfect solution, right? It's like an 80-20 solution. Let's have something and get as much value as we can, and then can we make it, change the Slide. So yeah, we can show that we have an integration to the Flink community, right? And based on those experience, we can propose the interface. No, we can propose an interface that allows us to create a way better integration that allows us to know what's the execution status, that allows us to track the changes in the data processing, and gives us some clear abstraction that will describe the data sets that are being written, read, modified, otherwise, and get a clear state transition, right? Because we know that streaming jobs are theoretically endless and boundless, but they always start and end if you like upgrade it or if something goes down, right? So we had this idea, we had other things to do in the meantime, and in the meantime, something happened. So we can get this slide. Yeah, there was a Flip 314, support customized Lineage job listener, and it was created by Fiang Yong from ByteDance, and it introduced several interfaces. First was like job status change listener that has on event method. That's basically gets a few types of events. Two of those are now, right? One job created event has lineage graph, and second has like list of status changes. So the old status of a job and new status of the job after this event happened. And the lineage graph has a list of like lineage vertexes, which are the interface for the sources, sinks, and other like not column level lineage processing nodes, but like everything that can read and write data. And lineage edges, which are relations between those sources. And we kind of, at some moment, we just look at it and say, like, well, did somebody in the meantime done the job for OpenLineage, right? They created the perfect interface that we could use to create the integration without us like doing anything. Well, close, not 100%. So the actual interface had a it was an interface for like single source or sink, right? That you can see right now, but it had like only one piece of information, right? It was a config for the lineage for the connector that was described there, right? And the actual lineage information that we could get was presented by like subclassing this interface, right? Implementing it, and like then providing some additional methods that actually help you determine what data is being read. So that wasn't the part that we were happy with, right? And the problem was that the Flip, which is like the a version of proposal in the community already passed, was scheduled to be released, or like scheduled to be written and released in some particular version, right? It wasn't implemented. And we are like 2 weeks after just noticed that it happened. And so why did we have a problem? Because it ties the listener, which is like the interface that you implement to get all of this information, the connector implementation, right? So to get the information from Kafka, we need to have actually understand that there is a class called Kafka Vector Lineage Vertex, or like, I don't know, Iceberg Lineage Vertex, or Postgres Lineage Vertex. Basically, our listener would have to know every connector implementation that there is in a while to get information from it. And this is impossible, right? Because there are also custom connectors. People have connectors that they implement inside their own like component. And there's no way that open source project can know them and like implement support for them. So it very much limits us to like open source connectors and the ones that are in Flink repo, actually. And this also is a problem that we had when we had our first version of Airflow integration. That not only tied us to particular connectors, but also to their versions. So let's say that in one version there is a bug and they fix it in the second version, right? Like, let's say it crashes or like as a null pointer exception and the second doesn't, or that they change the name of the method. It means that we still have to go back to the reflection that we presented before or we have to do some runtime checks of a version, right? If the connector has this version, then go into this code path, and if not, then go into the second code path. And this is very hard to maintain and basically breaks each time the stuff like that happens. And then we like have to catch up, right? So what's the solution? And we actually resolve this as of this week. And next, can we get the next slide? Yeah, so the OpenLineage basically way and the idea is to get the collections close to the data transformation, data processing, right? So our idea is to add a dataset interface to Flink and make connectors implement it and make the lineage vertex implement like the list of datasets that they actually touch, right? So for sources, what they read from, for things, what they write to, and make them fill it. And like this breaks the coupling between the collector and listener because they both depend on shared interface that is basically doesn't change between versions, and if it changes, it makes only forward compatible. So let's say we have the situation where there's a bug, right, in one version of connector. So what we do is like we go, the connector fixes the bug, releases the next version, and we don't have to update our listener to make use of it, right? As long as it returns the data sets that are specified somewhere, it's all good, right? And there is a mechanism even that extends the data sets with facets, which are basically the same as OpenLineage facets. So the end result is that we have a interface in Flink that is OpenLineage, but not quite named OpenLineage. And that's basically a lot of things map directly to what we do, but it's not enough. It's easier to convince the community to create an interface that there is consensus than to depend like on a library that is third party. And we think it's actually a good solution, right? The community is comfortable with the solution, and we can have a clear one-to-one mapping without breaking anything. And now after this gets implemented and released, the Flink integration will be much superior to the current one. And thanks. Any questions? Oh, and thanks to Fang Yong and Peter Huang that I discussed this issue, and basically who helped me push this through, make this happen.
Well, thank you very much, Maciej. And I just want to give Maciej a shout out because what time is it there?
Not
Anyways,
that late, it's 7:38.
7:38 p.m. Okay. Well, thanks for joining us after work hours anyway, even if it's not.
Thank you, Maciej, and it's a great job coordinating with the Flink commuters on this. This is great collaboration.
Okay. Our next item is discussion items. Does anybody have a discussion item?
Michael, I'm happy to give a general update at the end if we have time.
Oh, that should be no problem. Yeah, let's move on to open discussion then.
Cool. So, hi everyone. So I have something to contribute. I was asked recently by Michael, hey, do I have anything to contribute about the Scala 2.13 support to Apache Spark integration? So basically, maybe some people don't know, maybe some do. At least I'm pretty sure the committers to the Spark integration do. It was quite so the context goes, we deployed the OpenLineage Spark integration into our own internal pipelines here at Booking. And the hopes, that things would just work, because we had identified a set of volunteer people who would run this in their own Spark pipelines on our on-premise Hadoop clusters, and it worked beautifully. And they were like, okay, fine, let's go to our new pipelines, which are running cloud, running different versions of Spark, and unbeknownst to us at that point in time, different versions of Scala. We loaded the jar into the images and expected it to run without any without any hassle, only for the jobs to fail spectacularly because the conflict in Scala major versions, or Scala binary versions as they're called. So the process, why this happens is a bit technical, but basically when we compile Java code, the compiler will inject the full class names or full type signature of a method, right? Which includes what its return type is, what its method name is, and also what its input parameter types are, right? It'll inject that into the class file. You may not be able to see this if you open a class file because of the bytecode that actually gets written there, but if you decompile it, you can see it. And so when you're calling, for example, a method in Apache Spark, like you're telling, I have this logical plan object, and you're saying, give me your outputs. So in Apache Spark, I can actually share my screen for this if you want. But the Apache Spark, it's over here. Cool. So what happens is, this is just plain old Java code, right? I have a demonstration factory, loads of demonstration, right? And this demonstration is just an interface that returns a java.util.list a string, all right? And I have a thing 2.12 and a thing 2.13. What they are is not important, just know that they have these on it, right? And this is Scala code for those that don't know. And when a Scala developer writes Scala, right, they see this. They see sequence, right, of string. And likewise, if I go to the source code for thing 2.13, once again, they see sequence of string. Absolutely no problems, all right? The Scala compiler does some magic when it's compiling for 2.12 and 2.13, where it will transform this method into its full type signature. In Scala 2.12, that is this one. This gets compiled to essentially scala.collection.sequence, all right? And in 2.13, this gets compiled to scala.collection.immutable.sequence. I'm probably typing, there's a typo in my, yeah, there is a typo. But basically it's saying it's two different types. And when the JVM sees that the same method has two different type signatures, if it doesn't know about the type signature, or rather if the type signature of the actual implementing class doesn't match the type signature it expects, it throws the classical runtime error, as you can see at the bottom here. So if I go to my Gradle tasks and I tell it, okay, run with thing 212, right? So this is going to run the code up here, right, against thing 212. Unfortunately, Gradle has to compile again, right? And it's like, okay, cool. My applicable Scala version is 2.12. My runtime is telling me I'm 2.12.12, and I can see I get a list of items. However, if I now say, cool, now I'm going to say run this thing with 2.12, but the runtime is Scala 2.13 essentially, right? It goes and explodes in my face, right? So we start seeing applicable Scala version still 2.12, right? But the runtime is sitting at 2.13, right? And I then get the infamous no such method error, right? So this is what we were experiencing And so the solution to this is to essentially take the entire application or the entire project and compile the things that can be compiled against the Apache Spark libraries that are compiled with Scala 2.13 to do that, right? So this is things like app, things like shared, Spark 3, Spark 3.2, 3.3, 3.4, and 3.5, those modules. And publish, have Gradle essentially produce a jar per Scala version, right? So for example, Spark 3.5 now produces a jar for 2.12 and 2.13. And then the trick is to configure app to correctly consume the relevant jars. Gradle allows us to do this, right, without much hassle. And then further, to make sure all of our work is actually doing what it's supposed to be doing, is to have app run its integration test against every version of Spark that we support and with their appropriate Scala versions. So this means when running Apache Spark 3.5.0 integration tests, we're actually going to run the integration tests against the 2.12 variant and the 2.13 variant. Similarly for 3.4 point whatever, 3.3 point whatever, and 3.2 point whatever, right? The outlier here is Spark 2.4. That one was actually compiled with, by default, Scala 2.11 and also Scala 2.12. So in that case, we only compile with the Scala 2.12 version and we only test with the Scala 2.12 version. Hopefully that explains what's happening. It is quite a challenging effort, particularly because the different versions of Spark require slightly different class paths, and it can lead to some interesting runtime errors. But you can have the screen back.
Thanks for the work you're doing, and it's, I think, a great contribution. We should always get the chance to review years faster.
Yeah, no problems.
Don't worry, we'll get back to all of them.
Yeah, no worries. Thanks for the reviews, by the way. And at least the feedback in terms of getting those integration tests running when I was going. I can't see the integration tests. Where are they?
Yeah, thank you so much. And you joined after our announcement of you becoming a committer, and so just want to congratulate you and welcome you properly to the project. And thanks for joining and sharing about this big contribution you're making.
Yeah, no problems. You're welcome. Much appreciated as well to be a committer.
And so Eric, you mentioned that you have an announcement or a discussion topic.
Just a general update. Thanks, Michael. I always like to join the calls and relay what I'm hearing from the field. So we add a little bit, excuse me, of a lull around the turnover of the year. People go on vacation, but things have picked back up again, and we're invested both in the Airflow and Spark integrations. So Damien, thank you for your contributions. Appreciate that. What we're generally seeing is interest across all Airflow hosted providers. Obviously, a lot of different implementation flavors, but I think the biggest common theme is, again, just to reiterate from last time, it's a lot of big enterprise adoption tied to real business value. And because of that, everyone really wants to press forward with things like trying to work out versioning conflicts and the like. So it's just exciting. I also mentioned last time we were considering releasing for the community a plugin for Airflow to help folks kind of level set on all their different configurations and help understand where they might be getting caught up. We've taken some feedback from the community. We're actually going to go with a DAG instead of a plugin. So we just think that that'll be easier for a wider base of folks to implement. So that's my update for today. Thanks again, everyone.
Thank you. That's exciting.
Thank you.
Yeah. yeah, excited to let the community know and amplify your announcement when it comes. It's great to hear. Okay, well, unless there are other discussion items, it's great to see everybody, and we'll be back same time, different place next month. So keep an eye out for that new Zoom link, and we'll hope to see you there and then.